It's episode 7, so it's probably time to talk about probability. Now, when I say probability, you probably think of a couple of things. Maybe you think about flipping a coin, and you have a 50% chance probability of having the coin be heads and a 50% chance of it being tails. And I think there's like a 0.00001% chance that it lands like the coin here, which is completely upright. Or maybe you think about probability in playing games, playing poker games or playing blackjack or other casino type games. And perhaps you understand that the probability is such that the house always wins in the end for these types of games. Let's look at a couple of examples. So if you look at a normal 6-sided dice, you have an equal chance of getting any side of a normal 6-sided dice. We call this a uniform distribution because you're equally likely to get any of the sides of the dice. How about a bag of marbles where you're going to stick your hand into a bag of marbles and you're going to randomly pull out a marble. And this bag of marbles contains 1 red marble, 2 green marbles, and 7 blue marbles. So whenever you stick your hand into this bag, you have a 10% chance of pulling out a red marble, a 20% chance of pulling out a green marble, and a 70% chance of pulling out a blue marble. So in this particular distribution, it's heavily skewed towards blue marbles because you're much more likely to grab a blue marble out of this bag. Let's look at a problem that we want to find the distribution of heights. We want to understand this question. How tall are global football, so soccer players? So we went and got a bunch of data on soccer players, and it looks something like this. And this is a fairly normal distribution. Most of the time heights are, where a lot of heights are all around the average, and the average is just under 6 feet for global football players. And so everything is really huddled around the average, and then you have, a few people at the extremes. So people like Dan Byrne, who's 6'7", is way over here on one side of the height, and people like Markin Garouk, which he is only 5 feet, is way over on the other side. And so you have these outliers, but most people lie within, that very tight distribution around average. And if I were to sample from this average, so if I were to take a random person out of all of the global football players, because most of them are concentrated close to the middle, most of the time when I grab one, just like grabbing a marble, most of the time I'm going to grab a blue marble. Similarly, most of the time if I take one of those soccer players, they're going to be close to that average height. We can draw a line over all of our data, and this becomes our probability distribution. And probability distributions are really cool because you can do all sorts of useful things. For example, here, if I have 2 different heights, and I want to say, what is the probability that if I select a global football player, I will pick someone who's in this range. The area between these tells you the probability of falling in the range between these 2 points. So, as an example, if I were to select a global football player at random, there's a 64% chance that they would fall in the range of 5'8" to 6'1". Just like we use data to determine the probability distribution of soccer player heights, AI models learn probability distributions from the data that they are trained on. This allows them to do really interesting things like predict that a cat is the one in this photo, or predict that a piece of text from an email that says urgent, click link now, they're probably going to predict that as spam. So an AI model that makes predictions or generations are really just making educated guesses based on probability distributions. All right, next up, we're going to talk about data. Thank you for joining me for this episode in the AI for People Who Hate Math series. This is an unscripted series that is inspired by my conversations with people who feel like they can't conceptually understand AI because it's just too much math. And it usually is. Most AI classes, tutorials, and videos are full of math. The AI classes that I teach as a professor have math on nearly every slide. I wanted to challenge this assumption that AI could only be conceptualized by people with strong math backgrounds. Especially as AI permeates our daily lives, I think it's important that everyone understands the technology, at least conceptually. Because without it, we're putting a lot of trust into systems we don't understand. Feel free to let me know in the comments if there are topics that you want to see covered. The initial launch is 20 episodes, and I am excited to see what you think.